Have you ever really stopped to think about what it takes to make millions of product boxes look exactly the same? Well, today, we're going to pull back the curtain on the incredible, totally hidden complexity behind something as simple as a perfume box. We're talking about the engineering it takes to make it perfect, not just once, but every single time.
Okay, so to really get why this all matters, you have to start with this data. Get this. The average European uses about 300 milliliters of perfume a year. But in Saudi Arabia, that number just skyrockets to a staggering 2,500 milliliters. I mean, that's more than 8 times the amount. And for a brand, that's not just some fun trivia, it's a massive planning constraint. When your customers are buying that often, you better believe they notice every single little inconsistency.
And this quote just illustrates the core idea perfectly. We're not talking about making a handful of beautiful boxes for a photo shoot. No, this is all about a high-speed, high-volume replenishment system where every single unit has to be absolutely perfect time and time again.
So here's how we're going to break it down. First, we'll look at this really unique market, then dive into what we're calling the pastel box problem. After that, we'll see how it was solved, uncover a second totally hidden challenge, and then wrap up with a huge lesson about mass production.
All right, let's jump into that high-stakes market. So, the client here is a major fragrance brand in Saudi Arabia. But with a twist, they specialize in perfumes for children. And as you can imagine, that adds a whole new layer of pressure to get the packaging exactly right.
So what makes this market so tricky? Well, for one, these perfumes are often bought as gift sets. That means boxes for different products are sitting right next to each other on the shelf, making any little color variation just pop out. Second, that repurchase rate is incredibly high, so customers spot it immediately if a new box doesn't match the one they just finished. And finally, and maybe most importantly, parents buy with their eyes. The packaging has to scream safety and pristine quality.
And that brings us to the first major hurdle. See, the client's whole brand identity was built on these clean, simple, pastel-colored boxes. The problem was, how do you make millions of these things look absolutely identical, order after order after order? Which really leads us to the big question, right? I mean, it looks so simple, just a plain box with a soft, gentle color. So why on earth is this one of the toughest challenges in all of industrial printing? Well, the answer starts with this key scientific principle, light fastness. It's a technical term, but all it really means is how well an ink can resist fading when it's getting blasted with light, whether that's sunlight in a storefront window or the super bright lights inside a mall. And what's so fascinating here are all the different things that are literally fighting against consistency. With light pastel shades, even the tiniest changes in pigment can look huge. Different batches of paper might have slightly different tones. Heck, even how thick the ink is and how it dries can change the final color. It's like a battle on a half dozen different fronts at once. So how in the world do you solve a problem that has so many variables? Well, the fix wasn't about just, finding a better color. It required a true engineering-led approach that got to the root causes of all that inconsistency. So here's the solution, and it's a crucial point. The team implemented a UV-resistant strategy for all the inks. Now, this wasn't just to stop boxes from fading on the shelf. It was actually a control method designed to prevent color drift between different production runs. The goal was to make sure that a box made in October looked absolutely identical to one made back in March. And the big question? Did it work? Well, the purchase orders tell the whole story. It started with a trial order of 50,000 units. But as soon as the client saw that consistency, the orders just exploded. This pattern is a classic signal in manufacturing. When you solve the repeatability problem, you unlock trust. And with trust, you get massive scale. In fact, by the end of just the first partial year, the partnership was already valued at 4.5 million RMB. This was never just about making pretty boxes. It was about building a reliable, scalable supply chain that fueled some serious business growth. But hold on, the story doesn't end there. As the partnership grew and they started working on glass perfume bottles, a new and even more subtle challenge popped up. And it's a perfect example of what we call invisible engineering. The problem wasn't the beautiful glass bottle itself. Nope. It was something most of us would never, ever think about. The tiny threads where the spray pump screws onto the neck of the bottle. We're talking about microscopic variations in the glass right there that could lead to huge problems, like leaks or evaporation. So the engineering team jumped in. They looked at the design and spotted a risk that would only show up at the absolute extreme ends of manufacturing tolerances. So by proactively modifying the neck height specification before it became a problem, they prevented a potential assembly line disaster, saving the client from leaks, evaporation, and just massive product loss down the road.
And all of this brings us to the big takeaway. This whole case study really reveals a fundamental truth about making things at scale. What looks simple on the surface is almost always propped up by complex, invisible engineering.
And really, it all comes down to two very different mindsets. The old way is just you approve an initial sample and kind of hope for the best. But the scalable, modern way, that's all about engineering for performance over time, anticipating and controlling for all the little variables that you know are going to pop up in mass production.
I just love this quote because it really gets to the heart of the matter, doesn't it? You can't just inspect for quality at the end of the line. True quality control starts way, way back with getting the geometry right in the design phase, long before a single product is ever made.
So the next time you pick up any product, I don't care if it's a soda can or your smartphone, take a closer look. What invisible engineering, what tiny battles against inconsistency are hidden right there in plain sight?